Assalamu alaikum. My name is Fadlullah Idris, and today I'm going to be discussing about the ardone 2.0, which is also known as Parrot. And it is a drone with a high definition camera, mostly for recording videos and taking pictures. It has a high definition camera, and these are its specifications, but I'm going to focus on the processor, which is a 1 GHz 2-bit ARM Cortex A8 processor with a 800 MHz video DSP. Okay, this processor, this ARM Cortex processor, is produced by ARM Limited, which is a company founded in 1990, and the company spun out of Icon Computers. This company, they produce the ARM processors, and the ARM processors are basically RISC processor cores, which means they are part of the family of the reduced instruction set computers that handle less complex instruction sets. And this ARM company, they don't produce the processor. All they do is they design the processors, and they sell the license to other companies, and those companies, they produce the processor themselves. So for the ARM processor, it is the leading provider of 32-bit embedded RISC microprocessor. It's because of its simplicity and its low power usage and its low system cost. Most of the mobile phones, networking applications, secure applications, smart cards, and SIMs, they prefer to use the ARM's processor because of its many advantages. And this processor, it is based on TDMI, which means TDMI is a acronym, and the T stands for Thumb 16-bit instruction set, which means this ARM processor, it can also execute Thumb instruction sets, which is in 16-bit, and D on chip debug support, which means it's also allow debugging facilities for software debuggers to perform successful debugging operations such as halting and restarting. And for the third, for the M, enhanced multiplier yield a full 64-bit result, which means it can yield, even though the instructions and everything is in 32-bit, but it can yield a 64-bit result with a high performance. And for this processor, it is in a 3-stage pipeline, and these 3 stages are fetch, decode, and execute. Now this is the diagram of the processor. These are the control signals. This is the write register, this is the ALU, this is the 32 multiplier that makes it into 64-bit from the 32-bit that it is. This is the address register, these are the control logic. And for the register, the ARM processor, it has 37 registers which are 32-bit long, which means they can contain up to 32-bit of data. Among the 37 registered, one is a dedicated program counter, which means it is used only by the program counter, 1 dedicated current program status register, 5 dedicated saved program status register, and 30 general purpose registers for the programmer. The R0 to R12 registers are the general purpose register. R13 is the stack pointer, R14 is the link register, R15 is the program counter, and CPSR is the current program status register. Okay, different states, because like I said earlier, the ARM processor is able to execute in ARM state and also in Thumb state. The ARM state, the instructions are in 32-bit wide, 32-bit long, and all instructions must be word aligned. And for the Thumb states, they are 16-bit wide, and all instructions must be half word aligned, but still the ARM processor can execute both of them. This is the ARM processor. Normally instructions are 32-bit, as we can see, but this time around it can also execute the 16-bit instruction in this format. and the thumb instructions are mostly optimized for code density and improved performance, and subset of the functionality of the ARM instruction set. And the memory access, the ARM also, it allows memory access such as load and store, and only 32-bit data bus for both instruction and data, and only the load and store can access the memory. Memory is addressed also as a 32-bit address space, and data type can be 8 bytes, 16-bit half words, or 32-bit words, as seen in the line. So that is all for me, and as a disclaimer, these slides I use, they are not for me, so I didn't make the slides. I'm using them as a reference, so I will paste the link of the slides in the link below. Thank you for watching. Assalamu alaikum.